can you guys see the links I put in? Oh, no, I didn't. Oh. Sorry, give me 1 second to copy the links for the passages. So this would be the first CP passage. We can just go on to the question, Daniel, since these are the homework passages. Okay. So hopefully there's a small group here today. So if you guys can put your answer in the chat, and then like if you are okay with being called on, also put like a little asterisk or a star behind it so we know we can call on you. You guys can go ahead and do that now. And let us know if you didn't get a chance to do this passage also, that would be helpful. Did anyone else get the answer? Okay. All right, so because no one else has put the asterisk in, we're going to go ahead and explain the answer, but C is correct. You can go on to the next slide, Daniel. There should be an explanation. So we're looking at the chart on the left to get our reduction potential. So the question is asking about this Gibbs free energy, which is the delta GO. And then when we're talking about voltaic or galvanic or electrochemical cells, these all have to do with this E cell. So to find the E cell, we need to know the reduction potential. So we find the reduction potentials from the table, then find the E cell and relate that to the Gibbs free energy change. So the previous cell is what was the palladium, which is the first one in the row, and then the copper. So we know this is a spontaneous cell, so it means that you have to have a positive E cell. So basically, for the sake of time, I'm not going to go too much into the detail, but you have to switch one of them. So I have positive 0.95 and then positive 0.34. You have to switch one of them to make them negative, and then you add them together. I know that my E cell has to be positive because it's a spontaneous cell. So I would subtract the smaller number, which is my copper, to get 0.65. Now the question asks, what if we switch copper with zinc? So instead of subtracting 0.34, we subtract negative 0.76, and that's what I'm doing here. And when I do that, I get an even higher E cell. So when I look back into the formula in the top left, if my E cell gets more positive, my delta G gets even more negative, so your delta G is further decreasing. Does that make sense? You can unmute yourself or put your question in the chat if it doesn't. Go on to the next one. In the wire setup in figure 1, which direction will the electrons go to the wire, and which direction is the current? So I'm hoping you guys have the passage pulled up. You can click on the link in the chat if you don't have it to do so. And then put your answer in the chat if you have it. Okay. Okay, and then Waleed, you said, I'm sorry if I'm pronouncing your name wrong. If you want to unmute yourself and explain.
Yes. So basically, I know that current and electron go in different directions. So if I find one direction, I just have to reverse the other one. By looking at figure one, I could see that the magnesium loses electron and it travels along into the other container, and that's left to right, and then the current is just the opposite of that.
Yes. Perfect. Thank you.
You're welcome.
So B is correct. And then basically, he had everything correct. So this is just explaining that with an image. So there's also another way to look at it. I think this is mostly the same way, but so what we're doing now is we're going to use like a standard metal, which is in this case, they're using magnesium. Oh, sorry, we need to look at magnesium, and then we compare it to like two metals. So we have metal W and metal. Oh, sorry. I'm so sorry about that. So we're on the left side of the chart, we're looking at magnesium, and on the top of the chart, we're looking at metal W. We see that there's no change when these two things react, which means that magnesium is not being reduced. So then that tells you what's being reduced is metal W. So electrons are flowing that way. So then your electrons are flowing from left to right, which means your current is going to flow in the opposite direction. Does that help at all? Okay, great. Next question. And then in a voltaic cell of Fe and Pd under standard conditions, approximate the current expected if the resistance of the voltmeter is 0.2 ohms. So if you have an answer, please put in the chat. All right, so we'll go on to the answer explanation. D is correct. So we are looking at PD, which is the first row, and then FE, which is 1, 2, 3, 4, the fifth one from the top. So it's a voltaic cell, so that's the clue that it's a spontaneous and that your E cell must be positive. So what happens is like you have these numbers, positive 90.95 and then negative 0.45. The voltaic part just tells you which direction you need to add them or subtract them. So your formula is always like reduction potential of one minus the reduction potential of the other. You just need to know which one goes in which side. So we need it to be a positive E cell, so we can't flip negative 0.95 because that then if we get negative 0.45 minus 0.95, we would get a negative number. So that tells us we need to do 0.95 minus of minus 4.45 to get 1.40. And then we use the equation V equals IR. So this is voltage equals current times resistance. And then we rearrange that equation to get current equals voltage over resistance to get 1.4 volts over 0.2 ohms equals 7 amps. Let's keep going. Right, and then if we create an electrolytic cell from metal X and metal Z, which will describe the electrode at metal X. Right, so we have A from both of you guys. That was correct. Daniel, can you go back one slide? Or was there no explanation there?
Yeah, sure. Let me go back.
Okay, thank you.
Was this it? Sorry.
Yeah, you know.
Okay.
Yeah, so basically what we need to do is figure out which of the metals is going to be your cathode and become reduced, and which one's going to be your anode and become oxidized. So the way they did this in the answer explanation was they took the two metals and then compared it with one of the ions on the left. So they used copper ions, that's the first row. When copper ions are reacting with metal W, it's forming a solid copper metal, which means copper is getting reduced. But then when copper ions are reacting with metal Z, there is no change. So what this is telling you is copper gets reduced when it reacts with metal W, but not with metal Z. So that is because metal Z must have a greater reduction potential than copper. So it's going to have a greater reduction potential than metal W also. So then we know that metal Z has a greater reduction potential, but this is an electrolytic cell, so it's going to be non-spontaneous. So metal Z is going to be the one that's going to get oxidized in this case because it's going to be non-spontaneous. So then what the answer choices had cathode in it and reduced. So if metal Z is going to be oxidized, that's going to be the anode. So metal X is going to be reduced and it's going to be the cathode. So the last step is to find out if the cathode is negative or positive. In an electrolytic cell, which is what this one is, the cathode is negative. In galvanic and voltaic cell, the cathode is positive. I know that was super dense, and some of this is just like memorization stuff that a lot of you might have forgotten from Gen Chem, but just brush up on this. And let me know if you have any questions right now. Then for this one, to measure the concentration of copper in the half cells, absorption spectroscopies utilize which of the following frequencies of light would have maximum transmittance from the graph below. Please put your answer in the chat if you have one. Let's keep going. So C is correct. So what you do is just maximum transmittance is least absorbance. So that would be at the 700 nanometer wavelength on the x-axis. So then you use the equation speed of light equals wavelength times frequency. Get frequency by itself to get frequency equals speed of light over wavelength. Do 3.0 times 10 to the 8 meters per second over 700 times 10 to the negative 9. So that's the conversion that you have to be careful of to get the answer. Okay. Let's just keep going. Okay, here you go, Daniel.
Okay, so I'll be doing the psych/soc Jack Weston part. So the link should be in the chat. So if you guys could go to that, that would be great. And so does anybody know what they got for question 1? Okay, so this question was basically talking about, okay, good, you got B, yes. This question was basically talking about groupthink, and this is a concept that appears so many times in like just MCAT, the actual test, or just content in general. So basically, you didn't even really need to read the paragraph. They're basically talking about homophily, which is basically like how similar things are. So, and also you can kind of think of groupthink as the more similar a group is, the more likely their opinions are going to be similar. So B is correct because we see that as a group becomes more similar, there's going to be less alternative opinions there. Okay, so did anybody get something for question 2? this was talking about if the study was modified to investigate the adoption of tridactic groups, this would introduce a new, what kind of variable? C, yes, that's correct as well. So, oh, sorry, this was for the last one. So yes, it's C. So basically, they're saying that they're trying to, in this question, they're kind of adding a new thing that they want to study. So you can think of that as an independent variable because they're adding another something that they wish to kind of find what the dependent variable is. So this is also something that appears a lot in the MCAT. It's very simple, and I kind of thought like, oh, I know this already. I knew this in middle school, but this actually tripped me up. So you need to make sure that you know that an independent variable is basically the cause. The dependent variable is the effect. That's what you're trying to figure out. So did anybody get anything for question 3? Yes, that's correct as well. So basically, you just had to look at figure 1 for this, and it's a little wordy, but basically what you see is that the circle groups, which are the didactic groups, and then the triangle groups, they're the network groups. So basically they're talking about didactic meaning 2 people versus a network, which is basically just a collection of people. Could be anything from, you can think of Facebook kind of as having that network of people in social media. So basically in this study, we see that like if there's one adopter, right, there's very little change. But then as we have more people in a group adopting, in this case, smoking cessation, we see that people start to also adopt it as well. And so we see that with the network group, which is the triangle, we have less adopters, even as the amount of people who are quitting smoking rises. So basically, we can interpretate that the unhealthy networks, they result in individuals having fewer ties to healthy individuals. So again, if anybody has any questions about these things, feel free to just say something in the chat. And then we'll move on to question 4. So if anybody has any if anybody got an answer for question 4, could you put it in the chat? So this was basically talking about, yes, B is correct. So this basically, a lot of the psych-soc terms, unfortunately, it's just memorization. So for this question, you kind of have to understand all of these terms, or at least one. So basically, in this case, the self-serving bias is a good example of it because you can kind of think of it as like you try to interpret things that like work out well for you. You kind of interpret those as, oh, that's my fault, like I created those. Whereas things that don't go well, you can kind of interpret that as, oh, it's other people. So like in a classic example, it's like, oh, if you get an A, it's because you're smart. But if you get an F, it's because the teacher didn't teach you well. So in this case, smokers who they weren't able to adopt the behaviors, they said it was because of stress. And regardless of whether that's a good reason or not, you can kind of see that as, oh, I wasn't able to do it because of an external situation. And then the other things like functional fixedness, that's kind of like when, for example, if you need to nail something in a wall and you don't have a hammer, but if you use, let's say, a brick, that would be an example of not functional fixedness because you're kind of thinking outside the box. And then self-fulfilling prophecies, those are things that kind of ultimately cause what you try to prevent. So we'll go on to question 5. If anybody got an answer to question 5, this is basically talking about different studies, like what kind of study was not present in passage 1. Yes, D is correct. So basically, again, you kind of have to know what these different terms mean. So experimental, that's basically when you think of like your standard science experiment, that's when you have dependent, independent variables, and you're ultimately trying to find a causational relationship. Quantitative, that just means basically numerical analysis. So usually the two go hand in hand. Longitudinal, that's like basically you kind of can see what it means. It's basically a focus on subjects over time, whether that's weeks, months, it could be even years. So as we see, like they say a 7-week period. So, and we can also kind of interpret that they're studying cause and effect here. So ultimately, you would narrow it down to mixed methods approach. And that's a little bit more difficult to understand, but mixed methods would be a combination of like numerical analysis and then also like subjective analysis. So for example, a very simple example of this would be like if a survey asked people, oh, how happy are you, from like, let's say 1 to 10. So that would be like operationalizing the value. So it's a numerical value, but then they could also ask them like, oh, how happy you are, like write a couple sentences. So those aren't really numbers. You need to like analyze those in a different way. So that would be an example of a mixed method. Yeah, so about longitudinal studies. So it's not, I'm not sure, where did you find that 7 weeks were not longitudinal?
Yeah, I was going to ask you about that too, because I thought longitudinal studies, they had to be like, you would think more so over like years, like a very long period of time.
Mm-hmm. Yeah, so that's unfortunately like the thing with the MCAT. Sometimes some textbooks might put a certain number to it and it's not exact. I mean, it's very difficult, right? Because then like maybe you could get to days and be like, oh, this is over a certain amount of time as well. But generally, I don't quote me on this, but personally, my thinking is that if it's over like a period, like a 7-week period, I would kind of start to consider that longitudinal. Basically, like if they're trying to see a result over time, but I do understand where you're coming from, because longitudinal studies, usually you think of like years with that. But I think with the MCAT, unfortunately, it's usually the best answer choice. So in this case, there really is no like subjective data. Like if you look through the paragraph, there's nothing about them asking like, oh, could you like, there's nothing observational. There's nothing about asking them like, oh, could you write an essay, describe how you feel? So ultimately, that's what would lead you to choose mixed methods approach. So yeah, does anybody have any other questions about that question or anything else in this passage? If not, we can go on to our live passage. So we're going to give you 20 minutes to complete these two. So there's going to be the CARS passage and then also the biochem passage. So if you guys want to complete those now, and we'll give you about 20 minutes, so 10 minutes for each.
Sorry, Daniel, do you think so? We only have 30 minutes left.
Oh, yeah.
So can you guys, do you think it's a good idea to have them vote on like if they'd rather do a CARS or a BBC passage, so at least we can get through one like in detail?
Yeah, we can do that.
Sorry about that. Can you guys like unmute or like either put in the chat if you would prefer to do a CARS or a BBC passage?
BBC.
BBC is fine. I also thought that this Balkan ethnicities was part of the homework. It was linked in an email, so I already did this one actually.
We can also go over all of them, like maybe not like just maybe we won't have time to interact with you guys, but also if you want, we can just go over our reasoning with them for both of the passages.
Yeah. So let's prioritize the BBC one, I guess. Is that okay? And then so we'll give you like 10 minutes to do that maybe, and then we can regroup and try to get through that one first. And then if we have time left, we can go on to the, yeah, I'm about to put it in the chat right now, Gina. So here it is.
Okay, so let's plan to meet back here. Let's say 141.
Are you guys about ready to go over it?
Yeah, I'm ready.
Yep, ready.
Okay. So does anybody want to say what they got for question 1 or put it in the chat?
I'm sorry, but before you do that, is there any way you could like briefly talk about what the best way is maybe to like attack the passages so you're not feeling, because I feel like I don't have like a very concrete way of like attacking the passages clearly.
Yeah, sure. So I'll tell you what I kind of did. I mean, it differs for different people, but I'll just say what my reasoning was. So the more you start to do these problems, you can kind of see that they kind of the passages and the questions, you can kind of group them into certain like concepts. So for example, for this one, when reading this and looking at the questions, this is kind of like a question where you have to follow the cycle. So you kind of have to see that tryptophan is the starting kind of reactant, and then it ultimately develops into serotonin. So for question 1, it's kind of, this question is basically asking you, do you understand this reaction? So and it's very complicated with they try to trick you with all these high long terms and stuff, and it's ultimately not important that like what, like I can't even pronounce 5-HIAA. Like it's just important to understand where they are in the reaction. So sometimes I would actually physically draw out. So for example, like 5-HIAA, ultimately this goes to this and it needs this enzyme to do it. And then this inhibits this. Sometimes you don't have enough time to do that, but basically that would be my reasoning when attacking this question. Does that help?
Yeah.
Okay. Yeah, and if anybody has any other questions about stuff like that, feel free to reach out, because it's almost just as important how to answer the questions as actually answering them. So does anybody have an answer to question 1? Yeah, so would you like to explain your reasoning?
Yeah, of course. So I went to the first paragraph, and there was a sentence that talks about the rate of the reaction is influenced by all these different factors. So then I just look at my answers and saw which ones were relevant, like A, decrease in tryptophan levels that will affect it. So I went down the list, and then C, I wasn't sure about, but I didn't see where I talked about phosphatase, so I just said that was the one that is not likely to contribute.
Mm-hmm. Yeah, so basically I feel like A and B you can kind of eliminate, because if you look at figure 1, they're both needed in this reaction to produce serotonin. I guess to start off, I like to kind of look at, okay, so it's saying which is not likely to contribute to SAD. So basically we see in the paragraph that like more serotonin or more of this 5-HIAA, these all result in less seasonal, I forgot what it's called, seasonal depressive disorder or something like that. So basically we're trying to look to things that how they affect the serotonin levels. So tryptophan and this oxygen tetra something, basically we can see that they're both needed in this reaction to produce serotonin. So more serotonin, less seasonal disorder. So we can kind of eliminate those. And then also an important thing to know is that a phosphatase kind of does the opposite of what a kinase does. That's very important to know for the MCAT. So you can kind of see in this picture, they kind of do the reverse of each other. So that's kind of how you can ultimately decide on C, because if you decrease the phosphatase activity, then you're going to result in increasing the serotonin production. So does anybody have any other further questions on that?
So you said if you decrease phosphatase activity, you're increasing serotonin production?
Yeah, so so if you read in the paragraph, it's kind of difficult because you also kind of have to bounce between figure 1 and then also what they say in the paragraph. But they say the rate of this reaction is influenced by tryptophan concentration, the calcium-dependent phosphorylation of the enzyme, and the cofactor availability. So basically, the enzyme that needs to be phosphorylated, it needs to be phosphorylated to produce serotonin. Okay. So does anybody know what they got for question 2? Yes, it is correct. Do you want to explain what you did, or I can kind of go over it?
Yeah, I can try to explain. So there was a sentence, a key sentence, where it said, in the last sentence of the first paragraph, it said 5-HIAA has a high ratio of filtration secretion to reabsorption. So I figured if it has a high filtration secretion, it's going to appear in the urine. So therefore, it's a good indicator of renal blood flow. So that was my logic.
Mm-hmm. Yeah, that's correct. Yeah, at first, honestly, this kind of confused me because when they said ratio, I initially looked at filtration to secretion ratio, but ultimately they're looking at the filtration/secretion ratio to reabsorption. So they're basically just trying to see like almost how efficient the nephrons are. So you can kind of think of it as having like a high renal clearance because it's able to flow and filter through any of these solutes in it effectively. So does anybody have any further questions on that, or? Okay. We'll go to, oh, sorry. Sorry about that. Okay. So I guess I'll just explain this one as well. This is also kind of something that appears a lot on the MCAT, so you kind of have to understand the differences between these chromatography different types. So I'm not sure if any of you know the iconic acronym SNOWDROP, but it's extremely helpful. So basically, Southern DNA, Northern RNA, Western protein. So for this, you can kind of eliminate them right off the bat because they ask to measure the association between tryptophan and its cofactor. So they don't mention anything about DNA, RNA, or protein. There's nothing about the central dogma or anything. So we can kind of cross off those. And then to look at ion exchange chromatography, again, even if you didn't know these terms, you could kind of see that there's nothing explicitly mentioned in the passage about like charges of these sort of molecules, even though they might be charged. There's nothing explicitly mentioned about that. So you can kind of cross that off. And then also just to further take home the message that C is correct, they're asking between association between this molecule and its cofactor. So whenever I think of affinity chromatography, I always think of kind of proteins and kind of how we know that enzymes have that the mechanism that they kind of just connect with each other, whether it's hydrophobic or ionic interactions, but they're very specific for each other. So it doesn't necessarily have to do with ionic charges. So that's how I got to that. Also, just another thing I'd like to mention, it doesn't help you answer this question, but I think it's very important to know that because it tripped me up a lot. So ion exchange, there are two types. There's the anion exchange and the cation exchange. And this is very confusing because at first I was like, okay, which is which? But basically remember it as for the anion exchange, the resin, which is kind of the physical substance, that's positively charged. And then whatever you're trying to target is negatively charged. So you can I help to remember this by anion exchange. You can think of that whatever the target is, it's exchanging with the resin, as you can kind of see here. Whereas for example, in this example, it's anion exchange. So you can see that the immobilized resin is positive. So it's not really, it's not changing. Like those molecules are still staying there. Whereas you can see the solute, which in this case is like a mix of amino acids, it's flowing through, they're connecting, they're disconnecting. So that's kind of being exchanged there. So that's just something I thought I'd toss out. So
I have a question. For snowdrop, does the O mean anything, or that's just part of that?
no, yeah, sorry, I should have
Oh.
explained that. The O is just there to make it so you're not like snidra, like, you know, it just makes it sound smoother. But yeah, definitely, that's one of those things where like it's just brute memorization, unfortunately, but that's extremely helpful. So
Thank you.
no problem. If there's no questions on that, does anybody want to say what they got for question 4? Yeah, so C is correct. This is, again, kind of knowing what type of enzymes there are. Here's a chart with a couple of them. You might see more, might see less, but these are kind of good examples. So we want to look at figure 1 to kind of see this reaction, and I have it right here. So we can see it's kind of just like the carboxylic acid is just kind of cut off. So basically, we're just breaking that bond there. So yeah, so and there's no like hydrolysis reaction. We don't really know anything about that explicitly. And oxo reductase, those are redox reactions. There's nothing that kind of indicates us to that as well. And then what's the other one? Isomerase. That's kind of, you can kind of interpret that as there's no really changing of isomers in this case. So yeah. Does anybody have any questions on that?
Could you explain why it was lyase again? Because I think I got it correct off like a process of elimination. And I was also going to ask, should we know the examples for each enzyme type too?
What do you mean by examples?
So you see how you said
Yeah. No, I mean, it's not necessary. You don't have to know it. I feel like, unfortunately, the thing with the MCAT is that a lot of the stuff you don't have to know, but it does come handy and it is helpful. So I would say you definitely want to know the type and the function. The examples, it can help you. You definitely don't have to know that. But like for in this case, we see that an example of a lysase would be a decarboxylase. And we see that that's this example right now, right? The carboxy group is being eliminated. So I would say it definitely can help you. And sorry, what was your first question?
No, you answered it.
Okay. And then since we're running a bit short on time, I'll go to question 5 and just kind of explain this one. So for this one, it's basically asking about what serotonin's effects are on muscles. And another thing with the MCAT is it's kind of difficult to know whether they're asking you a question that's kind of just discrete and you need to use background knowledge, or it's in the passage. So for example, for this question, I kind of took a little bit too much time on it because I was like, okay, I know serotonin affects your mood, your appetite, but I didn't remember anything about muscle. But if you look, it does say very clearly in passage 1 that, where is it? That the release of serotonin, basically, it has several functions, including the initiation of peristalsis. So basically, then you kind of have to know what that term means. And it's basically just the movement of food through the digestive system. And it's almost kind of like a caterpillar-like movement, like it kind of squeezes it as it slowly moves down. And also it'd be helpful to know that all of that, the digestive tract, it's all smooth muscle. So that would eliminate choices A and B. And then also you have to know that this also tricked me up a little bit because it says initiation. So at first I read that as inhibition, but it says initiation. So basically it's initiating smooth muscle contraction to move food through the body. So does anybody have any questions about that? I thought that was a little straightforward.
This is almost like a discrete question, right?
Yeah. See, and that's the thing that always got me because it is a discrete question, but I don't know about you, but I personally did not know that serotonin was responsible for peristalsis. So like in that sense, you do need to read the passage that it says it initiates it. But besides that, everything else is a discrete question.
Right. Thank you.
Yeah, often you can, this is, not exactly, it doesn't happen all the time, but generally speaking, like the shorter the question and the less like numbers and specific terms and specific enzymes it throws in, the more likely it is to just be discrete, like, oh, what is peristallus? Like what, is it smooth muscle? Is it skeletal muscle, etc.? So yeah. So does anybody have any questions on, since we're kind of reaching the end, does anybody have any questions on anything we've went over? Any concepts you need to further clarify?
Sorry, I posted a question. I missed all the past sessions. Is there a link where I can rewatch the videos for the sessions that I missed because of Teams?
Yeah. So could you send an email? So Daniel, if you don't mind advancing to the last slide to this email, and then we'll send you a direct link. It's all on Teams, the recordings, but we can also just send you like a direct link so it's easier because I know Teams has been like really hard to navigate. So can you send that email?
Yes, I'll do that. Thank you very much.
Thank you.
Should we?
Oh, thank you. Sorry. I also just have like a small thing to say. So I joined late, and I think a couple of the people joined late because the email sent out the wrong Google, I
I
think.
know that was my bad. I'm so
Yeah.
sorry.
And there wasn't an update about that, so yeah.
Yeah. Sorry about that.
No
We'll
worries.
do better next time.
Yeah. We just messaged in chat and Teams and stuff, so that might be why there was like less people, but yeah.
I was gonna ask. So do we have to? Because I'm still trying to like struggle to navigate with the what is it called? The Teams. Do we have to ask somebody for a code? Because I finally created my account because I just been using a link. So do I have to ask for a code, or where can I find the code to enter the specific pre-med peers?
Could you also send an email, Ngozi?
Okay.
Yeah, because I think Sim would be better to answer that.
No problem.
Yeah, sorry about that. Just because like we're also a little bit new too, so we're having a little confusion about it as well. So if you could send the email, that would greatly help.
From my understanding, we were all added like manually because we had trouble like accepting the invitation and it wasn't quite working. So like once we were manually added, then I could like write in the Teams chat and access stuff.
Yeah, so Ngozi, if you like use a certain email to sign up for the prep course, make sure it's the same one that you're using to sign in to like Teams. That's also been a problem for some people.
Okay, because I think I'm using two different. Like I have a team. Okay. All right. So you said use the same email
That you paid for.
that you paid with. Okay. All right. I'm gonna have to double check then. All right.
Thank you very much. Bye-bye.
Thank you.
Bye.
My last question, I'm sorry. I was wondering because I didn't feel like, surprisingly, I didn't feel like the questions were that hard, but I was wondering because I'm trying to like perfect the technique of how to approach the passages. So initially what I did first was I went through each question and I answered some of them based off of what I thought they were like, if they were just discrete questions. And then after that, I just go and I start reading in the passage. But sometimes I notice it's like, I don't know if it's like maybe I need to just slow down and just focus on understanding what I'm reading. But then when I'll come back and do the questions, it's like I'm just like a little bit lost, if that makes sense.
Yeah. So again, it's kind of like different people might have different opinions, but for that, I would recommend that you not do that, just because when you're actually